Lesson 5, we're going to talk about intervals of increase and decrease, talking about some real life situations. We're going to sketch some graphs out to show what's happening in these situations. So on 189, Martin will ride his bike from his house to his aunt's house. He has two different routes he can take. One route goes up and down a hill. The other route avoids the hill by going around the edge of the hill. How do you think the routes will differ? What do you think about the relationship of speed and time? So, what we're going to be talking about here, they're going to be asking us to draw a graph basically. So, we draw a graph. It's not necessarily going to have specific numbers, but it's just going to be a general graph about what this is going to look like. When we graph this, the speed is what we want to see a change in, so we're going to make that on the y-axis so we can see how the speed goes up or down. The time is on the x-axis because time is just always going to keep going no matter, it's not like, oh, it's 10 o'clock, my speed must be 5 miles per hour. They're not, it's not related to it that way. The time just goes no matter what our speed is doing. So we're going to do two sketches here. We're going to do one sketch if we go around the hill. And we're going to do one if we actually go over the hill. One thing they don't really specify here is whether we are just getting started or whether we're already started biking and then we get to this hill. We're just going to make the assumption that we're just getting started here. So if we're just getting started, what would our speed be? 0. Okay, so this is going to be starting going at 0, 0 if we don't have any speed. Okay, so we're going around the hill. So what are we going to do? What's going to happen to our speed here? It's going to go up. Okay, now when this goes up, it's not just going to be a vertical line because it's going to take some time for us to build up the speed. So as our speed is increasing, some time is going by. So our line has to angle over a little bit. Okay, we're going to make some assumptions here. We're going to assume at some point, okay, it's somewhat level here, we're going to assume. And at some point he's probably going to level off on his speed, right? He cannot just keep indefinitely increasing his speed. So at some point his speed is going to stay the same for a little bit. And then there's technically two things that could happen here. I mean, there's lots of things that could happen, but easily you could argue two things that could happen here. And this is not assuming any traffic lights or stop signs, anything like that. At some point here, potentially he could start getting tired. If he starts getting tired, what's going to happen? His speed's going to go down. So maybe his speed goes down a little bit here. We're just guessing. His speed could go down because he's getting tired. And then maybe he starts going at this speed. And then when he gets there to his aunt's house, then he's going to do what? He's going to stop, so his speed's going to go to 0. Speed's going to go down to 0. Okay? Now that second part there where he had a little dip in his speed, we don't know that for sure. Okay? Again, that's just taking a guess here. It could have been he goes at that speed, the whole way, and then he starts slowing down getting there. Okay? So that's going around the hill. Any questions about around the hill? Okay, now we're going to look if he would go over this hill. So if he's going over this hill, again, we're going to assume he's just at a stop to start out with here. And he's going to still increase his speed a little bit to start out with, right? Okay, so he's increasing his speed. Maybe he's staying at that speed a little bit. And let's say at this point is when he hits the hill. What's going to happen? He's going to start slowing down because that hill is hard to climb. Okay, so his speed's going to go down. This is when he gets to the hill. Okay, and then maybe he can maintain, or maybe he has a couple drops. Maybe he drops off a little bit and tries to go at a certain speed, then maybe he drops off again. I don't know. Okay, now he starts getting up to where the hill is leveling off. There's a little bit of a flat spot on the top of the hill here. Now what's going to happen? Okay, it's increasing. He's picking up speed. And then, you know, maybe he gets back to his regular speed for a little bit here. And then he starts going down the hill. The speed's going to increase. Good. Okay, starts going faster going down the hill. He's got gravity working with him. Okay, and then at some point here he's going to end up getting to the bottom of the hill. So whatever that's going to look like here, I don't know exactly, but and then he's going to start slowing down again. Okay, and then maybe he gets back to his regular speed a little bit here when he's back on level ground for a little bit, assuming his ant doesn't just live right on the other side of the hill. And then at the end he would slow down and stop again. Okay, so again, that's just kind of a sketch of what's happening, and that's what we're going to be looking at, one of the things we'll be looking at in this lesson. So example 1, an express train reaches its travel speed of 150 miles per hour a short time after leaving the station and travels this speed for an extended period of time. What does the qualitative graph of the distance the train travels over time look like once it reaches its travel speed? Okay, so the qualitative graph they're talking about is just like we were looking at a minute ago. Qualitative graph, it's looking at a relationship between quantities without numbers. So it's just basically, like I said, it's kind of a sketch of what's happening in general. Okay, just looking at the qualities, you could say, is the base of that word qualitative. Alright, so when we go to sketch this, first of all we need to label the x-axis and the y-axis. If time is involved, almost 100% of the time is going to be the x-axis, because time doesn't care what's happening otherwise. Time will continue on. So time is the x, the distance is the y here. And another word they're talking about that we're looking at in this lesson is interval. So interval is a period of time between two events or points in time. So basically it's kind of like each segment is an interval. All right. So like kind of with going back to our last example, they started out biking and then they get to the hill. Getting to the hill, that's going to start our next interval of what they're doing. All right, so you can see they sketched that out here. So they gradually increased over time what the speed of the train was. And I'm not sure exactly why they have the little change in our slope here, why it's not just a constant increase there. You know, you could argue that maybe our graph could just be something like this all the way. Okay, and this one actually a little bit different than our other one. This is talking about the distance rather than the speed, but the distance is just going to keep increasing. Distance that the train has gone is just going to keep increasing over time. Alright, so if you look at the try it, the graph at the right shows another interval in the train's travel, which best describes the behavior of the train in the interval shown. So this one, if we look at this graph, we're going to talk about is time increases or decreases. Well, time increases. Time doesn't decrease that I've seen. Okay, so as the time increases, the speed of the train decreases. So this is maybe the train is getting back to making it, you know, it's going to make a stop somewhere, so its speed is decreasing. And then we could say the function is increasing or decreasing then. Decreasing. Okay.